In section 2.5, we talk about truth tables. So truth tables are just going to be a way to help us analyze complex statements. So let's do an example. Let's consider this statement we have below. If we go through and read this, right, it says we have P or Q and not P and Q. So let's take a second and think about that and see if we can rewrite that in different terms, right? So we have P or Q and not P and Q, right? P and Q is both of them. So I can think of this as P or Q, but not both. So if we're ever having trouble sort of breaking down these statements, it's helpful to use truth tables to help us look at which situations or which truth values for P and Q make a statement correct or make the statement true. So how do we go about doing this? So we're going to do what we've done for truth tables all along. Oops. We're going to take our two statements P and Q, and then we'll list out all possible truth values. So we'll have true, true, false, false for P, and then true, false for Q. And now I want to go through and build up my truth table entry for my statement P and Q or not P or Q and not P or and Q. So what I recommend for doing this is to break that down into its little component statements. So I have a P or Q. I have a P and Q. And then that P and Q gets a not P and Q. And then finally, luckily I can resize here. Finally, I can put in my overall statement P or Q and not P and Q. So if I call this guy 1, this guy 2, I can think of this as not 2, and I can think of this as 1 and not 2. Okay, so now we can go through and build that truth table. So starting off, I've got true or true, so that's true. Remember, an or is true as long as one of the statements is true. So the second one is true as well. False or true gives me true. That or is only false when both of those statements are false. So I'm just drawing that truth table for this entry here. For P and Q, the only way that's true is if both P and Q are true. If either of them is false, then that statement is false. Now I need to negate P and Q. So I'm just doing the negation of this one before it. So when a statement is true, its negation is false. False goes to true. So we can build that up. And then finally, I'm going to put together my 1. So I'm going to look here at this row and my not 2. So I'm only going to get something that's true if they're both true. So true, false becomes false. True, true becomes true. True, true becomes true. And false, true becomes false. So overall, I can see, maybe we can just rewrite this below so we can kind of see the first and the last thing together. For my P, Q, and then P or Q, and not P and Q. That overall truth value looks like this. Just going to copy that over. False, true, true, false. So it's true when exactly one of P and Q is true, and it's false if either they're both false, so if they're both, or if neither of them are true, which is what we said in the beginning. So again, here the idea is that we can use these truth tables to help us analyze these statements. So we really break them down in their component statements and use the properties we know about those component statements to build them back up. Let's go ahead and do one more example. I want to make a truth table for P and Q implies P or R. Right, so we have this really complex statement here. It's got 3 letters, P, Q, and R. So I need to think about all of the combinations of these. What I like to do is I'm going to start with the last one, and I'll alternate my true falses. So true, false, true, false, true, false. I guess I have to know how many there are. But if I have n letters, then each of them has 2 options, so I get 2 to the n options. Right, so for 3 letters, I get 2 to the 3 equals 8 options. And by letters here, I really mean statements. Right, so for these 3 different statements, P, Q, and R, I should have 8 options of truth values. So I start all the way in with them alternating. Go back 1, I'm going to have 2 trues, and then 2 falses, 2 trues, 2 falses. And then go back another 1, I'll have 4 trues, and then 4 falses. So you can build this up whichever way you want, but that is a way that we can make sure we get all of those possible combinations. Okay, going through here, we've got my P and Q, and then that P, oops, didn't draw P there. P and Q implies P. And then finally we'll do P and Q implies P or R. Right, so I'll think of this as maybe my 1, and I can call that P2. So this is really 1 implies 2. And then maybe I called that whole thing 3. So this is 3, or we'll just label that R as 4. So we'll kind of put these together as we go. Let's first look at the and here. So for my and, P and Q, that's only true when both the P and the Q are true. So I need 2 trues. As long as at least one of them is false, then that statement will be false. So the first 2 are true here, and then the rest of those will be false. Now, for P and Q implies P, I need to look at my P and Q. So I'm just going to go ahead and write this really small in here. This is not the value for that. This is just our sort of helper, our scratch work. And that needs to imply, and then I'm going to copy the P entry down. True, 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 false, 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 false. Okay, so now we can determine if each of these statements are true or false. So recall that P implies Q is only false, right? When you have sort of this counter example to it, it's only going to be false if you have a if you have a true going to a false. So I only get false if I have true goes to false. True goes to true, that's fine. True goes to true, fine. False goes to true, fine, 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 fine. So all of these are true. If you ever end up in a situation where you get everything being true, that's called a tautology. So a tautology is a statement that is true for every possible input. So the statement P and Q implies P, that's a tautology. All right, that makes sense. P and Q. Well, if I know P and Q is true, that means P has to be true and also Q. And if P is true, then I can imply P. So that does make sense that that's a tautology. All right, we're not quite done. Here I need to do P and Q implies P or R. Since I have an or, it's going to be true as long as one of those things is true. I know that this one is always true. So again, this will also be a tautology. So we can label that also a tautology here. Let me spell that right. Tautology. All right. So here's a question for you guys to work on and we can discuss in class. I want you to make truth tables for each of these two statements. So P and not P, or Q, and P or Q and not R. So this one should have those 4 rows, and this one will be those bigger one with 8 rows. So we'll talk through those in class.